Hey guys, it's me. It's Tuesday, December 2nd. I'll be back on campus tomorrow, Wednesday. So, although I'm getting better, I'm sure my jokes are getting better as well. We're going to start today talking about specific rock evidence in support of Alfred Wegener's theory of continental drift. This activity today is going to totally rock, but if the jokes are bad, it's not my fault. Fault line. All right, here we go. All righty. This is the activity paper that you need today. Rock evidence, it's 5.1b. You'll pause, go get it, glue it in your binder. All right. Rocks in certain parts of Africa and South America are very similar. The rocks in South America, here's our country of South America we've been talking about, show what's called a graining pattern, similar to the pattern on rocks in the Sahara Shield of Africa. And this is our Sahara Shield that's over here. There we go. Graining patterns refer to a unique pattern found in rock. For example, they can be the crystal size and crystal color. They can also be lines like the rock that you see here. You can definitely see how there's a similar line that goes all the way across. And what scientists are saying is that they found specific rocks that they look like this over on South America, and on Africa, the pattern continues when they lock them up. um, just next to this area in Africa, are rocks that are much younger, only 500 million years old. Would a similar pattern be rocks found in Africa? And so you've got size, color of crystals, you've got lines, and then you can also have just a solid color with no lines. The fancy word for lines in rocks is called striations. While confident that they would find it, a group of geologists went to South America looking for a sharp boundary between old and new rocks that was the same as the boundary in Africa. And here is the evidence that they found. When you look at this map, here is South America and here is Africa. And this is the idea that Wegener had, although he couldn't prove it. This is how he thought the continents were put together. They found the rocks of similar striations and color and lines. They found them exactly in this place they thought they would be. Some skeptical scientists, however, thought that their discovery was just luck. Down here, this word cratons is a fancy word for large pieces of earth or large pieces of immovable rock. And there are some younger mountain belts that are here. But essentially, what they're saying is they link, they connect in these areas. And so, what do you think? They found a sharp boundary between the old rocks with the graining pattern and the younger rocks. The same sharp boundary can be found on South America and Africa, where their shapes match. Not only did they find specific rocks, but they also started looking at diamonds. South American diamonds are found in a rock that's called kimberlite, a type of volcanic rock. They're small in the west near the Pacific Ocean. These diamonds are bigger in size the further east you go towards the Atlantic Ocean. They went to different mines. They were able to find different types of samples. And as you can see, as they go from west to east, the diamonds get larger. So I guess the question for you is, when they go to Africa, would that pattern continue? Well, when they went to Africa, diamonds in the kimberlite, same type of rock, the Sahara Shield of Africa, they also increase towards the east. The diamonds get larger when they start at the west and as they go towards the east. And so scientists are able to use this evidence from diamonds. It's just one more piece of the puzzle. The gradual increase with distance seemed to show that there was a pattern. Now, this alone is not a pattern. rocks with the same striation or color, that's not evidence enough, but it definitely is a piece to the puzzle. Alfred Wegener used this evidence from diamonds. He also used evidence from the matching mountains on both sides of the Atlantic. Please make sure that you finish your activity as you're going through this, and I'll see you later.